Alright, thanks Greg. Welcome everyone to the Nutrition Management of Sheep and Cattle webinar. This webinar is part of the Next Gen project, which is Young Sheep and Beef Producers of the Future project, which is funded by DAFF, the Department of Fishery and Forestry. Today we've got Desiree Jackson from DD and Longreach speaking to us. Desiree is a scientist, beef scientist in Longreach. Thanks Desiree.
Thanks, Alex, and thank everybody for taking the time to come to the webinar today. I should be able to get to the slides and answer your questions over about a period of an hour, and that's why I asked Alex to send out, a list of potential topics that you wanted me to speak on. I was under the understanding that I was just going to be speaking about sheep. My background is actually in cattle, but they're both ruminants, so there's a lot of relevance between the two species. So if you have questions as I'm going along, I prefer you to ask them then, because I just find it's very distracting for you if you've got a question that's not answered and I'm moving on to something else. And if you're a bit shy about putting your hand up and asking, you've always got the option of sending a question through the chat. And if I don't pick up on it, Greg and Alex will. So I'll get started, and you just ask questions as we go along. Okay, so the first question I always pose to people, and it's a little bit easier when you're actually looking at everybody to ask this question, what is a ruminant, as distinct from an animal that's a monogastric such as a horse? The thing that's unique about ruminants is that they have a number of chambers where they're able to process fairly indigestible feed, because they've got microbial population in the gut. So there's a symbiotic relationship happening between the microbes in the gut and the animal. And basically when we're feeding our sheep, cattle, or goats, we're actually feeding both the bugs and the rumen and also the animal. And it's very important that we maintain a very healthy rumen. And some of the things we do with our management will have a huge impact on that, both in a positive way or in a negative way. So we need to keep the microbes in the rumen ticking along. And the reason we need to do that is because, one, they break down feed that's extremely indigestible. And certainly if you were looking at putting a horse on the very same feed, they wouldn't have the capacity to be able to utilize the nutrients from that feed that cattle and sheep can. So they're able to break down very indigestible feed. But in order to do that, they can't survive on fresh air and sunshine. They also have to have nutrients as well. And if they are not provided from the pasture, they need to be provided from supplements. And I'll get into a bit of detail on that. The other important thing about ruminants is they actually produce energy for the animal. But one of the things that's really important to remember about ruminants is that, and I'll just skip a slide here, couple of slides, is that they produce a microbial protein. So they multiply in numbers and they become the actual source of protein for the animals, and they actually produce up to 70% of an animal's protein requirements. So if we're not looking after the bugs in the rumen, it means that the animal is not going to be able to absorb as much protein as it would under a condition where the rumen's quite healthy. So it's really important that we look after those bugs. So we'll talk about that a little bit more. So just to give you an idea, we've got, and this is actually, I've got a couple of slides in here from the Nutrition Edge workshop that we deliver. And basically in the rumen, you've got three main types of bugs. You've got your bacteria, and they're in a huge population. You can have between 10 and 200 billion bacteria per gram of rumen fluid. So there's quite a few of them. But having said that, their populations can decline very, very quickly within the space of a few hours, because they become the source of protein for the animal. And if the rumen's not looked after, those animals, bugs won't continue to multiply. We've also got anaerobic fungi, and they're pretty important, particularly as the feed's drying off. There aren't as many of them as what there are bacteria, but they become very important during the dry season in that they can break down some fairly indigestible feed. The other ones we've got are the protozoa, and they tend to be a bit parasitic. They're just there for the ride, and they just feed off the other microbes in the gut. And that's why we feed things like put rumensin into supplements to actually try and kill off those protozoa, because they provide no benefit to the animal. They're a bit like worms in your stomach. All they do is, live off the nutrients that you're taking in and provide no benefit to the animal. So we try to reduce those numbers. Having said that, once you get a bit of rain and you've got a bit of green feed, the protozoa do tend to disappear. But they become a problem when the season gets particularly dry, and that's the time when animals aren't getting enough nutrients from the pasture as it is. So if we can control those, then that's going to be a benefit to the animal. And just to give you an idea of what bacteria look like, they're not too exciting, but that's what they look like. Very, very small, but very plentiful in number, and that's obviously looked at under an electron microscope. So just to reiterate, those bugs provide most of the protein that an animal is going to get from its diet. Some of the protein that the animal consumes from the feed, it will actually bypass the rumen and it will get digested in the small intestine, and that protein is what we refer to as bypass protein. And it doesn't have to come in the form of cottonseed meal or copper meal, and you probably hear about bypass protein a fair bit. All grasses have a component of bypass protein as well, and all that simply means is that that component of protein that's not broken down in the rumen, it bypasses the rumen and gets broken down in the small intestine. And sometimes it's very high quality protein that makes up bypass protein. And that's probably most important for your young animals and your lactating animals. So what are the main nutrients that are required by stock in Western Queensland? Pretty much the same as what they are across all of Northern Australia. And when I'm speaking about Northern Australia, I'm talking about north of the New South Wales-Queensland border. Basically, the main ones you got your protein, energy, and your minerals. So, your main minerals, Northern Australia, the biggest mineral deficiency would be phosphorus. And if you're living on mulga country, you certainly would have a problem with, phosphorus deficiency. And also in mulga country, you would have issues with sulfur. Sulfur is not actually deficient in the soil, but it gets bound up with the feed on mulga country, so it's unavailable for the animals to absorb. So those animals need to have sulfur year-round in the diet, and they also need to have phosphorus year-round in the diet. So if you have mulga country, your animals should be on a phosphorus and sulfur supplement year-round. What normally happens is protein is the first nutrient that tends to become deficient if you have no endemic mineral deficiencies, and later on in the dry season, energy can become more deficient. In some of the areas of Western Queensland where we've had huge amounts of rain over the last couple of years, in our arid areas, the country just can't handle those large falls of rain over an extended period of time. We get a dilution of nutrients and too high a stem to leaf ratio, and we find that the energy levels tend to drop a lot earlier in the year. So last year, it was August, and a lot of properties had deficient energy levels in the pasture, and this year energy became deficient even earlier, even though there was a big body of feed out in the pasture and it wasn't rain damage. The country just can't handle it, and that's why we have to have droughts, much as we don't like them. So what supplements provide which nutrients? Just to give you a broad idea, if we're looking at protein and mineral supplements, all your urea-based dry licks, blocks, and some wet licks, such as things like your Anapro and your Dunder, they will tend to provide the animal with nitrogen, and generally speaking, non-protein nitrogen, so things such as sulfate of ammonia and urea. The protein that's in those licks tend to be in there not to provide the animal any significant amount of protein, because the animal just isn't consuming enough for that amount of protein meal in there to make a difference in its protein intake. They're in there for two reasons. They're in there to improve palatability, and they're also in there in some cases to actually absorb moisture if it does rain during the dry season. So that just prevents your urea from going into solution with water, because it's highly soluble, and it just prevents urea poisoning. But generally speaking, they're there for palatability. They don't contribute much to the nutritive value of the diet coming from protein. Most of the nitrogen's coming from your urea. They also can supply minerals. Now, normally when you see labels, you see a list of minerals as long as your arm. But generally speaking, it's your macro minerals that you would be looking at. So things like phosphorus, calcium, sulfur in your licks. And generally speaking, it's phosphorus and sulfur. Most of the country, most of your tropical areas, your calcium levels are usually quite reasonable. There are a few pockets where you can get calcium deficiency, but for the most part, particularly if you're in a country that's phosphorus deficient, your country has reasonably high levels of calcium relative to phosphorus, so you don't need to do things like add lime to your licks. And in fact, I'll talk about that a bit later, but I'd actually recommend against doing that because it's very counterproductive if you're trying to supply phosphorus to your animals. So some other examples, your blocks, your urea-based loose licks, any proprietary mixes that contain urea, and dunder. So anything that contains a reasonable amount of urea means that the animal's not going to be eating half a kilogram or more of that particular lick, which means that you're supplying that animal with nitrogen, so the bugs in the rumen can convert it to a source of protein, or you're supplying minerals, or you're supplying both. And that's it. It doesn't matter that it contains molasses, it doesn't matter that it contains crushed lupins, or grain, or cottonseed meal. If it contains a reasonable amount of urea, it means that all you're really supplying is urea to that animal and a bit of mineral. That's a really hard one to come to terms with. If we're supplying bulk supplements to animals, so the animal's eating that feed on a percentage body weight basis, or, in the case of sheep, if they're eating, 250, 300 grams a day, in the case of cattle, they're eating 500 grams or more a day, or it's expressed on the label of a feed bag as percentage of body weight recommendation, then we're talking about supplementing that animal's energy, and because we're talking about organic feed, it's going to contain protein as well. The exception being molasses. Molasses has a very small amount of nitrogen in it, so it doesn't really supply much protein at all, and it supplies a lot of good quality energy, and that's why we put urea in there. It just balances up the energy in the molasses. So some examples are your whole cottonseed, lupins, protein meal, and fortified molasses. The other thing that we need to be really mindful of when we're supplementing animals is that we've got the balance right between energy and protein. And this is one of the things that I often see where people waste a lot of money is in sticking with that just feeding protein for too long and not being mindful about where energy's at. And generally, when I see this, is when you see extremely high intakes of dry licks by stock. They're trying to satisfy a craving, and it's usually because it's becoming quite energy deficient, so they start gorging on the dry licks more and more. And it's not because they're requiring more protein, it's usually because they need to be upgraded to an energy supplement. And I see a fair bit of that through, I do a lot of diet quality analyses and reports across Queensland and the NT, and I see a lot of cases where people are putting their animals onto urea-based dry licks, and energy is way deficient for those animals, and basically they're wasting a lot of money. If energy is deficient in the diet and we're putting a lot of protein into those animals, we're putting a very expensive form of fertilizer onto our pastures, because all it's going to do is come out the other end. The bugs in the rumen, in order to be able to process the protein that's coming into the diet, whether that comes in the form of urea or in the form of protein from pasture, need to have enough energy in the diet to be able to do that. And just to give you an example, if we want to produce 100 grams, that's microbial crude protein, so that's the protein that's utilized by the animals from the rumen microbes. We need to have 12 megajoules of energy going in there. So 12 megajoules of energy, that would be about the equivalent of a kilo of grain or a kilo of molasses. So we need to have a balance between energy and protein in the diet. And once animals become energy deficient, blocks and urea-based dry licks all become pretty much a waste of money, and they are very expensive. You're talking about hundreds of dollars to $1,000 a ton for a dry lick, and if those animals need an energy supplement, they tend to be a lot cheaper on a tonnage basis, although they do tend to eat a whole lot more of them. But that's where they need to go. So what happens to pastures as they age, and this is pretty important, particularly for ruminants. I said to you earlier that the bugs in the rumen have a capacity to digest really poor quality feed, and that indigestible fraction of a plant is actually in the cell walls. And that's because your tropical pastures are subject to a lot of environmental stressors such as lack of rain, which we haven't had much of lately, also very dry weather conditions and extreme heat and also wind, so that plants need to protect themselves. And as the season dries off, we see an increasing proportion of those cell wall contents to actually protect the plant from the weather, and we get a relative decrease in the amount of all the goodies that are found in the cell content. So your protein and your mineral and your carbohydrates, they tend to overall decrease. Now here we see that sugars go up, but that's because there's a relative decrease in the protein levels. The total amount of sugar most probably doesn't go up in the plant, but it just increases on a percentage basis. But overall, your cell contents tend to decrease as the season starts to go on. Your cell wall content tends to increase. And this is why we do things like feed urea to our animals. Urea actually helps to increase the rate of flow of pasture or roughage through the rumen so that the animal can actually consume more pasture. So the pastures have lower quality as the dry season goes on. We feed urea to our animals, and we can actually increase their dry matter intake anywhere between an extra 20 to 30%. So they're actually consuming more pasture, and it's a cheaper way than actually supplying that protein energy in the form of a supplement. And we can do that to an extent, but once energy becomes very deficient in the pasture, then urea is not going to have as much of a benefit. The other benefit of urea, of course, is if we actually feed 1 gram of urea, we actually get almost 3 grams of accrued protein equivalent for each gram. So it's a very economical form of supplying nitrogen to the animal. Okay, here we've got pretty standard nutritional curve showing the energy level and protein levels of pasture. So when we look at the digestibility of the pasture, it's highly correlated with energy. So if you were actually to go out and get a diet quality analysis done, it would tell you what the digestibility is of the diet that your stock are on. And from that, we can actually get a really good idea of whether your animals are energy deficient or not. So as you notice, early in the growing season, for the first couple of weeks after you've had rain, your digestibility is extremely high. The problem is it only stays up there for a couple of weeks on tropical pastures, and then it tends to do a bit of a nosedive. And once you start to see your plants flowering and seeding, you know that diet quality has dropped a fair bit, but you should still get reasonably good production in this area. Most of the time, your diet quality will sort of spend time around here, so it will be quite adequate for dry stock, but it does tend to become deficient for animals that are in late pregnancy or lactating. So timing of what we do management-wise is really important. If we know that the bulk of the time the diet quality is going to be in this particular area, then we should be trying to ensure that our animals are in peak lactation or in late pregnancy, somewhere in here, so that the pasture can supply the nutrients that the animal needs, and it just cuts down significantly on our supplementation costs. This is just an example of Mitchell grass. It's green leaf dry matter digestibility, just from a grazing trial out here at Rosebank, and it's just to give you an idea that even if you've got green feed, your energy levels will still be quite variable. So, level of greenness isn't always the best indicator of the quality of the pasture. And this is actually just one pasture species. In most areas where you've just got native pastures and you haven't got sown pastures, you're going to see that many different species that if you go out and get a pasture analysis done, it most probably isn't going to be representative of what the animals are going to be eating anyhow, because they're going to be selecting different species at different times of the day. Again, this is looking at crude protein. So all these green lines, that's all green leaf Mitchell grass, and these red lines are actually dry leaf Mitchell grass. And basically, and this would apply to other species as well. If your feed starts to dry off, provided you don't get any small falls of spoiling rain or frost, They'll be slightly deficient, and you most probably have to feed urea to your animals, but if you don't get any damaging rain, you can actually sustain those animals on a urea-based lick for a very long time before they fall significantly enough that you have to upgrade them to something like a protein supplement or get rid of those animals. Generally speaking, if you do have a lot of green leaf in the pasture, the animals can select the bulk of their diet from green leaf and they can maintain themselves pretty well. Some of the work that we've done with diet quality analyses, though, is we found that once animals begin relying on grass solely for their diet, that for any higher producing animals such as weaners and animals in late pregnancy and animals that are lactating, that they can't maintain their nutrient requirements on grass alone. They actually need to have some level of herbage in the diet. Diet quality analysis, we'll talk about that. These are a couple of ringers from South Galway that we're pretty excited about learning how to collect dung samples, as you can see. So what's NIRS? It's near-infrared reflectance spectroscopy, and basically what you're doing is you're actually grabbing a bulk sample of dung from a group of animals of the same class as stock, drawing those samples off and shining a beam of near-infrared light through that and actually looking at the spectrum. Okay, and the reflectance that you actually get depends on the chemical bond, so that's obviously going to depend on the plants that actually make up that dung, and the energy is either absorbed or reflected. Now, the diet quality test was developed on tropical pastures or tropical grasses, which are all your C4 plants. And once we start to get a lot of forbs in there, all your herbage, they're all C3 plants. It can affect the reliability of the results. So the reflecting spectrum looks something like this. And what they did with the NRS diet quality analysis, they actually looked at pen feeding groups of steers, and they would take a sample of the forage that those animals were eating in the pens, and they would get that analyzed by conventional lab methods. So you'd find out what energy, digestibility, protein levels were. Then they would take some of that forage and do an NRS analysis, and it would come up with this spectrum. Then they would also take a dung sample and get an NRS spectrum as well. And then through mathematical modeling, they were actually be able to produce equations to determine what the diet quality was like. So some of the information you would get would be crude protein, fecal nitrogen. Fecal nitrogen is probably not that important for you if you go and get an analysis done, but it's certainly important, if for the person that's actually trying to interpret the results. Digestibility is really important in that it gives you an indication of the energy level of the diet, and it also gives you some idea of how much pasture those animals are going to eat. And obviously, if you know how much pasture they're going to eat, what it's like, you know how many nutrients they're actually going to be taking in from the pasture and whether they're going to be deficient or not. Percentage non-grass. Non-grass is all your forbs, browse, any bushes or legumes that the animals are eating. So, if you're on mulga country, it can get a little bit tricky because they could be eating mulga leaves or they could be eating gidgee and there's a big difference between the two. Both are very high in protein, but all your native browse species, even though they're high in protein, they're bound up with tannins, which means that the animal can't actually absorb all the protein from the browse species. So when we get an NRS result, we might see really high protein level, but if someone has indicated that the animal's on forest-type country or on mulga or a country where there's some edible browse, we can soon work out whether that protein's high because there's a lot of browse in there, and that's usually because your digestibility tends to be pretty low as well. We used to look at live weight gain, but we found that it was a little bit rubbery, so that one got thrown out. So how can we use the information from a diet quality analysis? Well, what we look at is dietary dry matter digestibility, crude protein ratio. What that means is we're looking at the balance between protein and energy. So we're saying if there's a lot of energy in the diet relative to protein, even if energy is deficient, even if they're both deficient but energy is not as deficient as protein in terms of meeting that animal's requirements, we can get a response from supplementing urea to that animal because protein's a lot more deficient relative to energy. So if we get into this area here where we get a ratio of 8 or higher, we can put out urea and we know those animals are going to respond to some extent. And that might mean that those animals could be maintaining weight, or if they're energy deficient, it might mean that, well, they won't stop losing weight, but we can certainly slow down their weight loss a fair bit. And it just might get us through to a break in the season rather than having to put out an energy supplement. So the higher the dry matter digestibility crude protein ratio, the more likely we are to get a bigger response from supplementing urea to those animals. So that's one way that we can use that information. And this is just another way to look at it in the form of a table. So when we look at, if we're looking at wet animals or anything that's heavy in lamb or calf, we're looking at digestibility levels here. If they're around this area, it means that they're getting enough energy in the diet. But what this is saying is the protein can be a bit deficient here, so we'll get a response to supplementing urea to those animals. When we get down to here, that's actually a deficient energy level for high-producing animals, but quite okay for any dry stock. And in both cases, we'll get a response to supplementing nitrogen. Here's another case where energy is it's borderline deficient for even dry stock, but we can still get a response to supplementing nitrogen because urea is protein's a lot lower relative to energy. So we need to know not just what the energy and protein levels are in a diet, but whether they're balanced with each other. It's always important to know how nutrients are balanced with each other in a diet. Another thing that we look at is if you want to get a phosphorus analysis done, you can. That's done through wet chemistry, which means that you need to get the phosphorus analysis done while the animals aren't on any phosphorus supplements, because the phosphorus supplement will interfere with the results. And here again, we're looking at what we call a phosphorus-nitrogen ratio, and all we're looking at here is the balance between phosphorus and protein. And all that's saying is, in this particular case, we're saying that there's enough phosphorus in the diet for the animals to be able to utilize all the protein in the diet. In this particular case, it's saying that phosphorus is very low in the diet, which means that even if the animals are getting enough protein in the diet, it's actually going to create a protein deficiency because the animals can't utilize all the protein in the diet. There's not enough phosphorus in the diet for the bugs in the rumen to be able to provide that animal with enough protein. So we need to make sure there's enough protein in the diet. And a classic case of this is during the wet season when energy and protein levels are very high in the diet. It's important that we get enough phosphorus into those animals. And often people focus solely on supplying animals with phosphorus during the dry season. They need it year-round, and particularly during the wet season. And that does create a few problems because it's not always practical to get it out, or it just might be too wet to get around, or animals just aren't seeking any phosphorus. But that's when their requirements are going to be the highest in country that's phosphorus deficient. Okay, if you're on brigalow-type country or Mitchell grass country, black soil country, phosphorus isn't going to be a problem during the wet. Phosphorus levels are very high, and most black soils. There are always exceptions to the rule, but generally speaking, they're reasonably good. But they can become deficient during the dry season. That's just an example of some NIRS results. So this is what you would get, obviously with a lot more detail, but in terms of results, this is what you'd get. In this case, it's saying that crude protein is probably quite adequate, although fecal nitrogen is saying it could be slightly deficient. That might be slightly overestimated. If we're looking at dry stock running in a paddock, that digestibility level would be saying that energy is quite okay for those animals. But if we had wet animals or late pregnant animals in the paddock, then those animals would require an energy supplement. So how this gets interpreted really depends on the sort of animals you've got running in the paddock. The ash content refers to any soil contamination. That's a pretty normal amount of soil contamination. Obviously, if animals are grazing herbage, they're going to be picking up a lot more soil. So that can sometimes happen. Or if you're collecting dung samples and there being dung beetles in the dung, then that's going to cause contamination. So you need to collect your samples from dung pats that haven't had any evidence of dung beetles. or we just get some cases where people contaminate the samples themselves by picking up soil. Non-grass, I mentioned before, is all your herbage, and without knowing any background as to the land system that this sample was collected from, it'd be very difficult to say that this is coming from herbage or it's coming from native browse. That phosphorus level is extremely deficient, and this is also very deficient, so even though protein potentially is adequate for the animals running in this paddock, they can't utilize all that protein because there's not enough phosphorus in the diet and it's limiting those animals. And this is also saying that you're unlikely to get a response to supplementing urea. So that's just sort of an example of the sort of information that you can get when you get your results, and obviously that's all written up as a report for you. Okay, I've sort of run through that, so I don't need to go through that. That's just an example of a diet trend for a property up at Longreach from an NIRS project that we are running up here. So just looking at crude protein levels. Okay, this is Mitchell grass country. These histograms are crude protein levels. These little green dots, that's all non-grass. And you can see in this case, they go up and down with protein. So that means that all the non-grass on this particular property is coming from herbage. Herbage is extremely nutritious relative to grass. So as the herbage level drops in the diet, so too does the protein level. And this is the reason why we shouldn't be running sheep and cattle in the same paddocks. It's not going to worry the sheep so much, but it will worry the cattle because sheep are a lot more efficient at being able to get hold of the herbage in the paddock, and that means they're out competing cattle for the herbage. And while the sheep might still be doing okay, cattle will tend to go backwards because their diet quality will start to drop back because the herbage levels have started to drop back. That gives you an indication of the protein energy balance in the diet. Okay, and all that's saying is it pretty much has the opposite effect. As the protein level drops in the diet, the energy protein balance actually goes up. It just means there's more energy in the diet relative to protein. Okay. So what's the difference between visual assessment versus NIRS? From the work that we did, the grass leaf stem ratio, it basically said that as the leaf stem ratio increases in the pasture, so does the energy level in the pasture. So if you're going out checking your waters, have a look at your pasture and see how much leaf there is relative to stem. And if there's a lot of leaf relative to stem, then it means your energy levels are going to tend to be higher. If you start to see the leaves disappearing from the plants, even if the plants are still green, what that'll mean is that the energy levels are starting to decline fairly rapidly. The other thing we found was that once that ratio became more than 25%, the protein level tended to increase as well. So we want to try and maintain as much green leaf in the pasture as we can. And we also found that there was less of effect in this grass leaf stem ratio if there was a lot of herbage in the diet. So if there's a lot of herbage, it tends to override any effect of grass because animals will naturally try and select as much herbage as they can in preference to grass. And you've always heard the old adage that, if sheep start eating the grass, it means they're starting to starve a bit. So they're always looking for herbage. Okay, NIRS for sheep. I just wanted to put this disclaimer in that if you are looking to do some diet quality analyses for your sheep, this technology was developed for cattle, so the reliability of the results can't be guaranteed. However, they are both ruminants. There is no other method for looking at diet quality for sheep. I do know of producers who have used this method for sheep and they've been satisfied with it. I guess the alternative would be if you have cattle and sheep running on your property, you could always sample your cattle and you would find that the diet quality for the sheep would be slightly better than for your cattle. Hey, how much does a sheep eat in a day? Well, if we look at their weights, if they're on green, lush pasture, you're generally looking at about 2.4 to 2.6% of body weight. So if you've got a 40-kilogram animal, it'd probably be eating about a kilo of pasture. Once they're on dry feed, that comes back a fair bit. It'll drop to 1.8% or even lower. I've seen it as low as 0.5% on black feed, so it does come back a fair bit. And that means they're taking in less nutrients at a time when the nutritive value of the pasture has dropped considerably. One of the other topics that everybody was interested in were what were the differences in requirements for different classes of stock. And what I put here as an example was a 40-kilogram ewe and what her energy requirement was at different stages of production and how that energy requirement changed from one stage to the next. Often it's this stage where we have the most trouble with our ewes, and not so much because the requirement has gone up, but just simply because as the uterus expands in sheep, it tends to really limit the capacity of the rumen to take in feed, so the animal's dry matter intake drops back considerably. And if this is happening during the dry season, this is why we finish up with a lot of incidences of preg togs during the dry. So the best thing we can do at this stage would be to supply animals or pregnant ewes with highly concentrated energy supplements such as protein meals or cottonseed, because they physically can't eat enough pasture to meet their nutrient requirements. So that's an aside on top of what the energy requirements are. Once she starts lactating, you can see that the energy requirement for that ewe goes up considerably. If we're looking at a 40-kilogram ewe that's eating a kilo of pasture a day, roughly, and then suddenly her requirement for energy has doubled. That 6.8 megajoules of energy, that would be about the equivalent of giving that ewe 500 grams of a grain supplement. So it's a considerable amount of extra feed. So how can we go about addressing that? Well, we need to be mindful about when we're lambing out. Obviously, if we're lambing out when the feed's green and lush, then we're more likely to meet that energy requirement during that period. Some people have very good reasons for lambing out during the dry season, but if we choose to go down that track of lambing out during the dry season, we just have to be prepared to supplement those pregnant ewes and lactating ewes with an energy supplement every single year. We just can't go without it because the pasture simply won't provide them with enough energy. We look at protein requirements. Again, you can see that when they get to that last stage of pregnancy, they increase dramatically, and again when those animals are lactating. Once those lambs have been running with the ewes for a while, you notice that it starts to drop away a fair bit as those lambs begin to rely more on pasture in their diet. So, if she's doing it a bit tough, that's a good time to consider pulling the lambs off the ewes. I might just go to this, just gave you a bit of an example. So, yeah, if we looked at that difference in energy requirement between the pregnant and lactating ewes, so just going back, the energy requirements, so here we're looking at 7.9 megajoules of energy, and here we're looking at 14.7 megajoules of energy, so that increase was 6.8. How do we manage for that? For the extra amount of supplement, one of the things that I tell people to use to calculate it is to look at what the need is over the feed that we're actually going to supply that ewe. So let's say we've got some whole cottonseed on hand. We say that she needs 6.8 megajoules of energy. We know that in 1 kilogram of whole cottonseed, we get 13.1 megajoules of energy. So all I did was divide 6.8 by 13.1, and it said that she needs an extra 0.519 kilos. Multiplied by that by 1,000, that gives us an extra 519 grams of whole cottonseed. So is that practical to feed that ewe? Most probably not, because she's just, eating that in conjunction with pasture, she's probably still not going to be able to meet her energy requirements. So we might have to sustain either a little bit of weight loss or change the timing of when we're actually supplementing those ewes. The other alternative is, can we put out a urea-based dry lick at the same time that we're supplementing whole cottonseed, so that we can actually increase throughput of roughage through the rumen and allow that ewe to eat a little bit more pasture. Go back to the slides again. Okay, if we're looking at growing sheep, I took a number of different sheep of the same weight. In this case, I've got early weaned lambs, so they're 20 kilos, little fellows growing at about 0.25 kilos a day. We need to have growth in those really, really young animals, whether they be weaner cattle or weaner lambs when they're very young like that. Otherwise, we'll have issues with stunting in those animals, or in the case of replacement ewes or replacement heifers, if we don't look after them from the time that we wean them to the time that we've mated those animals, their age of puberty is going to be a lot higher. They're not going to conceive when we want them to, and they're likely to become very unreliable breeders down the track. You know, they might produce offspring in the first year, but undoubtedly they're going to miss the second year, and most probably they're going to miss every second year. So we really need to look after those replacement females. Otherwise, just be prepared to sell them and cut our losses with them. So that energy requirement for an early wean lamb, that's about the equivalent of a kilo of grain. And obviously, they're not going to be able to eat that much. A 20 kilogram animal, you know, let's say she's eating 2% of body weight, it's only going to be eating about 400 grams a day. So it's going to be very difficult to try and expect that sort of growth out of that animal. I looked at a replacement ewe lamb, a 40 kilogram one, growing at 180 grams a day, compared with a replacement ram lamb, same weight. We probably want slightly higher growth in that ram lamb. He's got a lot more growing to do. He's going to be a bigger animal. Or comparing them with a wether that's just maintaining weight, a 40 kilogram wether. You can see there's a pretty big difference in the requirements. Obviously, we're expecting a lot more out of our ram lambs, but there's a huge difference here between our replacement breeding stock versus our wethers, and they need a lot more attention than what our wethers do. And I've just put another example there. I think I'll show you the next slide. Looking at protein, again, pretty big difference in their protein requirements. These three groups, all 40 kilos, slightly different growth rates between them, but a huge difference in what their protein requirements are. So I've got a bit of a working example here. Okay, just looking at the wether in the ram lamb, if we said this is during the dry season, and they're going to be eating, say, on average 1.8% of body weight, that was a bit of an educated guess. And we said, you know, the pasture could be about 4%, which is roughly where it is about this time of year when we haven't had rain. ME is just the energy level of the pasture. ME just stands for metabolizable energy, so about 4 megajoules, so that's a bit ordinary. Could be around 5, but we'll just look at protein. So a 40 kilogram animal, I multiplied it by 1.8% of its body weight. That's what it's going to eat. 0.72 kilograms, which is the same as 720 grams. I multiplied it by 4 over 100, which is 4% of its body weight, and multiplied that by 1,000 grams. So I said that animal is taking in 28.8 grams of protein from the pasture. We said that wether needed 48 grams of protein. So what I said was it's got a deficiency of 19.2 grams of protein. So how do we address that? And this is during the dry season. Well, we said it needs 19.2 grams of protein. Urea every gram of urea will supply 2.87 grams of protein. If urea has a crude protein equivalent of 287%, which is what makes it such a good nitrogen product to use. So I just divided the 19.2, which is what we need, by what urea supplies, and that gave me an answer of 6.7 grams of urea. And that's quite a realistic amount of urea to supply to a sheep to meet its protein deficiency. So all we'd have to do for that wether was put out a urea-based lick and just monitor how much it's eating so we know it's getting enough. So then I looked at this little ram lamb. He's a bit of a problem. He needs 243 grams of protein. I took off what we would feed him with the urea, and it said that we still needed 214 grams of protein. Okay. Oh, made a bit of a blue here. Yeah, that shouldn't be there. It should actually be 243 divided by 2.87. So I'll just calculate that. So he needs about 85 grams of urea, and there's no way in the world he can eat that amount. We don't even want our cattle to eat that amount because that'll probably kill them. So he's not going to be able to eat that amount. But let's say we'll just stick with this figure. We took off 8 grams of urea. Let's say he still needs 66 grams of protein. I divided that by what we could give him if we fed him whole cottonseed, which is 317 grams of whole cottonseed. So if we're talking about a 40-kilogram animal and feeding him whole cottonseed, is that something that is practical to give those ram lambs? Or would that be something that we would find a little bit too extravagant? So we might want to drop our growth expectation back maybe to 250 grams from 330 grams. And then we're more likely to achieve our goal. So we really need to be realistic about what our expectation is for those animals and whether we can actually supply them with the nutrients to meet those growth rates. So we start off by actually getting a handle on, what is the diet quality of the pasture and what are the requirements for our animal. So how much urea do we need to put into a lick? And this is a question I get asked a fair bit, and I'm sure Kay does too, and Alex. And it depends on a number of factors. So one, on the type of country. Some countries just a bit hungrier and animals will eat huge amounts. I know there's some properties up in the territory, up in the top end, where they put up to 46% urea into their licks to try and slow down intake of lick. And it has nothing to do with getting more urea into the animals. It has more to do with trying to reduce the palatability. It also depends on the diet quality and the class of stock that you're supplementing, because their urea requirements are going to be slightly different, and what other ingredients you have in the lick. So if you've got a lot of palatable ingredients in the lick, such as protein meal, you might need to bring the urea right back. In the case of sheep, you might need to drop that right back to 8 or 10%. In the case of cattle, you might need to drop it right back to 15%, and it really depends on the area that you're in. So, if we're talking about properties where we've got some rugged country, well, you can get away with putting out 30% urea straight away. It really depends on a number of different factors, and there's just no one rule of thumb that we can recommend for all properties, and we need to take into account a number of these different factors. And the other thing we need to look at is the minimum required intake. How much do we want those animals to actually be consuming? But a few basic rules of thumb for requirements. For sheep, you were looking at a range of anywhere between 5 to 8 grams of urea a day. Okay. With cattle, for weaners, you're looking at about 30 grams a day, and adult cattle 50 to 60 grams. Now, if we want to actually stimulate appetite in the animal by supplementing urea, we need to supply them with enough urea. So in the case of cattle, we need to supply them with at least 30 grams of urea a day if we want those animals to actually go out and consume more pasture. If those animals are only eating 10 or 20 grams of urea a day, they most probably aren't going to be eating more pasture. Okay, feeding licks. Some rules of thumb are we need to balance nitrogen with sulfur, so protein with sulfur. The more nitrogen we put in, so the more urea or protein meal we put in, the more sulfur we need. One of the things that I found, and other beef officers have probably found as well, is that a lot of feed companies are putting in lots and lots of Gran-Am into the licks because it's very bitter and it controls intake. The problem with that is Gran-Am is very high in sulfur, so some of those ratios are getting down a fair bit. We're looking at trying to maintain a ratio of about 10 to 1, and some of the ratios I've seen are anywhere between 3 to 1 to 4 to 1, so you just need to be a little bit careful. The exceptions being on mulga and basalt country, which are sulfur deficient, and obviously higher amounts of sulfur are required in those licks. We also need to balance phosphorus with calcium, and we need to take into account what the animals are receiving from pasture. A lot of feed companies will maintain that 2 to 1 ratio, calcium to phosphorus. That's the ratio we're looking for, but not in the lick. We're trying to balance the lick with what they're getting from pasture. So calcium's pretty high on most country, with some exceptions. So, we strongly recommend you don't add any lime to your licks. If you're using things like Kindofos or DCP, all those products contain calcium anyhow. And if you put extra calcium into licks where it's not needed, that calcium will get flushed out, and it will also flush out the phosphorus. So it can actually exacerbate a phosphorus deficiency. So you really need to know what the calcium-phosphorus status is for your country before you start putting lime into your licks. Also build up urea gradually, the intake, and this is so that the bugs in the rumen can actually adjust to that increase in the urea level in the lick. So we don't want them to be gorging on urea in the first week. And sometimes just adding a bit extra salt is very effective for trying to control intake. Just finally, conscious of the time, but just to wrap up, just something else I wanted to add in was the time off feed. I did mention that the bug populations in the rumen, they can decline very rapidly, and one of the times when this occurs is when animals are off roughage for any period of time. So once they're off any roughage for 12 hours or longer, the rumen bug populations decline very rapidly, and this is because the bugs in the rumen will turn over, anywhere from 1 to 2 hours to a bit longer, and they become a protein source for that animal. Those animals, bugs then are replaced, provided there's sufficient roughage. But if we do things like muster our animals and hold them in yards for 24 hours, the amount of roughage in the rumen will decline, and along with it the rumen bug population. And sometimes if animals aren't doing well once they've been mustered and worked through yards, that's the weight loss is attributed to the stress of the muster, when in actual fact it's most probably the stress of the animal not being supplied with any roughage. So a good rule of thumb is if those animals are being held in yards overnight, they really should be supplied with some roughage. I know that sounds very extravagant and it's a big paradigm shift, but if those animals aren't supplied with any roughage and they're held off feed for 24 hours, it'll take up to 3 weeks for those animals, for the bug populations to actually get back to normal again and the animals to start producing again. So it really does set them back. Okay, 12 to 24 hours, the bugs are starting to shut down, and once the animals are off feed for more than 24 hours, there's a real decrease in rumen function. So if you're buying any sheep or cattle, either off of computer auctions or even through sale yards, be really mindful of when those animals have last had a feed. And even if you're trucking them home, if you've got any distance to truck them, I'd recommend that you supply them with a bit of hay at the sale yards before they're actually trucked home. If they're looking pretty tucked up and look like they haven't had a feed for a few days, even if they look like a bargain, they most probably won't be, and don't be surprised if they do nothing for you for the next couple of months. They've really had a setback, particularly weaners, which haven't got the the same rumen capacity of bug populations that adult cattle would have. And we get into a situation known as dead bellies, and it takes a fairly long time to reestablish the bugs. So even if the animals start to consume a lot of pasture and they appear to be filling up, it takes up to 3 weeks to return to normal. So that's it's a really important thing, and something I push a fair bit, that if animals are held in yards overnight, make sure they've got access to roughage. Just some final take-home messages. Really important to know what the requirements are for the class of stock you're feeding. So I gave you some examples of differences in requirements for different classes of stock and how those vary greatly, and what might work for one class of stock mightn't necessarily be effective for another. If you can get a diet quality analysis done, I'd highly recommend it. If you're on country where you've got a lot of temperate pastures, the technology is not going to work, but if you've got country where you're on tropical pastures, it certainly will work. Find out which nutrients are deficient. Find out which nutrient is most limiting. Sometimes a year it might be protein, and later in the year it might be energy, and you need to know when that change occurs, because it might mean that you'll have to change your supplements around, or you might choose to offload animals or wean animals as well. It'll also help you to determine which type of supplement to feed. And calculate the cheapest lick on a dollars per unit nutrient basis, not on a tonnage basis, because at the end of the day, it's actually the nutrient we're actually trying to supply to the animal that we should be calculating the cost for. And continue monitoring the diet and the animal nutrient requirements, because they're obviously going to change. And if you're doing diet quality monitoring, we recommend you do that at least every couple of months. And it's really important to pinpoint when those animals move from being protein deficient to becoming energy deficient. Once animals become energy deficient, they start to lose weight really rapidly, and by the time you visually see weight loss in those animals, it's been about 6 weeks since they've been deficient, and it's very difficult to recoup their weight. So if you can do some diet quality monitoring, you can actually pick up when animals are starting to lose weight before you can visually see it in those animals. And finally, if you get the opportunity to do a Nutrition Edge course, I'd highly recommend it, and I do believe Alex is organising one for early next year.
Thanks, Desiree. We'll open up to questions now. Is there any questions from anyone?
Yeah, Anthony Glasson, Desiree. I was just wondering, temperate pastures. What's temperate pastures?
Things like your clovers, or where you get a lot of C3 plants. So if the bulk of your pastures is comprised of herbage, then those are all C3 plants. Kay might be able to give you some more specific examples from down in South Queensland. Kay?
Yeah, but they're doing the tests when they're on those sort of pastures. They're not very accurate. Is that correct?
No, they're not very accurate, because the original tests were done with C4 plants, which are your tropical grasses.
Yep.
So even, for example, on Mitchell grass country, if you can get a lot of herbage on Mitchell grass country, once it gets up to about 30% herbage in the diet relative to tropical grasses, then that can start to interfere with the results a little bit as well. With the testing, that NIRS testing, it'd give you a really good gauge of exactly what type of licks to feed, wouldn't it? Like whether you stock a sulphur deficient or and that sort of thing. Well, the NIRS testing, it'll test protein and digestibility. You can get a phosphorus test done. That's by wet chemistry. Sulphur would be different. You wouldn't be able to test the sulphur level. But you could test phosphorus by wet chemistry. If you're on mulga country, you can take it as a given that those stocks should be on sulphur year-round. So if you're from Thargomindah, you'd be on a bit of mulga, would you?
Yeah, we have got some mulga country, yeah.
Where it gets a bit tricky is when you've got a mixture of land systems. You've got some good black country mixed in with your mulga country, and cattle are sort of working both. That makes it a little bit trickier.
Yeah, and those tests, what sort of cost are they?
If you're getting an NRS test done, you're looking at about $45 to $55 a sample. So that would be for a bulk sample from a group of animals out of one paddock. And if you want to get a phosphorus test, you're looking at about $35.
So, just wondering where we send these, or where we could send a dumb sample to.
Yep, George, if you want to give, if anyone who's interested wants to give Alex your email address, Alex can let me know, and I can get some kits sent out to you, or I think Alex has got some kits on hand as well. So if you want to catch up with Alex, he can give you some information on where to send those samples.
Yeah, right out. Thank you.
So they go to Simbo Alliance at Brisbane.